Hello everyone and come on in. Welcome, welcome. Drop a hello in the chat. Hello all, come on in and let me know if you can hear and see me well. My name is Alexandra and I am your host for tonight's webinar, Getting Started with Excel, Python, and Machine Learning. Welcome all. Feel free to drop a hi in the chat and check out the links in the chat that I'll be dropping throughout the night. First off, the slides for tonight. If you want to follow along, download this presentation that we'll be showing you tonight, then feel free to go to the chat and just find the link for these slides. Welcome all and come on in. My name's Alexandra and let's begin by discussing our agenda for the night. So tonight, first, we'll introduce a bit about Lumiwealth and myself, and then we're going to give 4 main topics introducing our Excel, Python, and Machine Learning course, which is coming in the end of February. This is the first time that we're running this Excel, Python, and Machine Learning course. So we're very excited to launch this new course. It will be launched on the last day of February. So we'll be having a spring semester with this fresh new addition to Lumiwealth. Tonight is just a teaser of this course, giving you a taste of some of the topics that we'll be covering and some of the projects that we'll be building, because this is a very hands-on project-based course. Tonight we'll discuss Excel versus Python. How are the two related? Why would you use both? Why would you pick one over the other? Because in this 8-week course, we will be learning how to transition from Excel to Python. So how you can build more complex projects in Python compared to what you can do in Excel. We'll also talk about data science and machine learning. What are these terms? What exactly do people do as data scientists, as machine learning specialists? What is this referring to? And we'll take a look at an example in code. So we'll get hands-on and look at an example of how you would build a project that uses machine learning and data science together, because the two work hand in hand. You might think it's a lot of topics, Excel, Python, data science, machine learning, but actually all these topics, they work very closely together. They're all interlinked. You'll likely be using all of them or most of them at once for a project. So we'll talk about how all these topics are related and how they work together in modern day projects. Then we'll also introduce all the 8 weeks. So we'll talk about what you will learn in the spring semester. Of course, tonight we can only cover so much, but in the 8 weeks, we'll talk about all the different projects that you'll add to your portfolio. And we'll have time for questions, but you can ask questions anytime, but we will have special time at the end as well. So let's begin by getting to know some of you in the chat. That way I can better tailor the webinar for you. So if you feel brave enough, please type out in the chat. Let us know, what is your background? What do you currently work as? Do you know how to code? And how much experience do you have with some of these topics like Excel, data science, machine learning? Usually my students don't have any experience at all. So we do typically tailor the courses and the webinars for complete beginners, but it does depend on the audience. So let me know if you have any experience, but usually I do expect absolute beginners. I will also introduce myself. My name's Alexandra, and I'm an instructor here at Lumiwealth. I'm also a software developer at Mammoth Interactive. And here at Lumiwealth, I also teach blockchain programming and Web3 development. But I'm excited to bring to you this 3rd course in the spring. You can also find this webinar on YouTube and on Circle. We will be recording this. We are recording it currently. So if you want to watch back, then you can either go to Circle or go to YouTube, where we will be posting this recording. And we still have a Discord channel, which you can join as well. Even if you're not a current student, anyone can join the Discord channel. Though the primary place that we check for questions and start discussions is Circle, which if you're watching live, then you're with me on Circle already. Throughout the night, feel free to ask questions. ask for clarification, that's totally fine. In fact, it's even great. Interactive presentations are the best, so please feel free to type away in the chat. Without further ado, let's begin with our first topic. So first up, we're going to compare Excel versus Python, because in the sphere, the realm of data science and machine learning, there's this transition away from Excel instead to using programming languages like Python. And we'll talk about why we see this move. Of course, we still use Excel to store files, to mostly work with Excel files, convert to CSV files, maybe build formulas, build spreadsheets, but to build kinds of modern day powerful data projects that you see at large companies, even small companies, we have to use something that's more powerful than Excel. And today that is programming. With programming, you can build projects and work with data in a way that Excel simply has limitations with. So Excel, I expect most of you will be familiar with Excel already, a program and application for storing data, building formulas. And Excel does have some programming that you can do in it to automate the way you work with your data. But Excel has its limitations. First off, data volume, how much data you can store and how easy it is to work with massive amounts of data. These days, for large data science, machine learning projects like self-driving cars, they require a lot of data, and something like Excel makes it hard to store and work with that much data effectively. So that's one limitation that we see today with Excel. Another limitation is speed in terms of running algorithms, which are automatic processes that a computer is doing. For example, if you want to sort through all your data or clean all your data, or if you want to train an artificial intelligence model, those things require high processing power by your computer. And if you're using an application like Excel to do those heavy tasks, those computationally heavy tasks, it's going to, number one, take a while, and number two, might not even be possible depending on the program. So that's another limitation of Excel. Also, speed in terms of how effectively you can work with data. Maybe you've worked with Excel for years and you feel pretty fast with it, but just the nature of how you have to build the formulas, build the languages, it is slower compared to when you're using something like Python on Excel data. So we're not getting rid of Excel. We're still likely going to be using Excel files, possibly to store our data, at least in the initial phase. But beyond that, to actually do the work on the data, to use the data for complex projects, Excel has limitations that it simply cannot do, or makes it very tedious to work with. Some more limitations are the security of your data and the types of algorithms that you can build. You can do some programming in Excel. You have Power Query, you have VBA, but the types of algorithms you can build are limited. So how do we address all these issues today? Well, that's where programming comes in. Currently, Python is the most popular language for data science and machine learning, which we'll talk more about later tonight. By using a programming language like Python to work with your data, instead of just Excel, you can really expand your abilities as a data scientist, a data analyst, whatever role you're playing in the data industry. So that's why we designed this course, to teach you how to code in Python, specifically from that data perspective. So how can you do Excel tasks with Python? And what can Python do that Excel cannot? Those are some of the things that we will learn in the 8 weeks. I expect most of you probably have some experience working with Excel, but how can you go beyond that to, expand your resume, build more powerful projects, get hired at a higher rate, all of that. Programming is the number one way to do that, working with data. Python in general is a very popular language, up there in the top 3 of coding languages. And the reason that we use these is to build more powerful projects, as well as to not have those limitations that Excel has. If I want to build a machine learning model, which we'll talk more about tonight, for example, if I want to build a facial recognition app, I have to work with facial data, which maybe you can store or start with Excel to host your data. But then beyond that, to actually build such a complex algorithm or model, I have to use a programming language like Python for those kinds of more advanced, higher level projects. And by using Python, you can improve your efficiency because it's faster to do tasks in Python compared to doing them in Excel. Whether you're doing it manually in Excel, of course, that's going to be slow anytime you do something manually, but also in general, the ease of building automation scripts, code that will automate tasks like cleaning your data, scraping data, collecting data, or manipulating your Excel files. All of those are easier to do with a programming language like Python because it's designed for efficiency. It's designed for these scripts. Excel, although it does have features that allow for coding in Excel, it's less streamlined, less efficient. With Python, you can also build advanced data science and machine learning projects, which we'll talk more about those later on tonight. Because maybe in Excel, you've been building spreadsheets, building formulas. Maybe you've been cleaning data or managing data in Excel. But to build higher level projects, like some of the ones we talked about already, self-driving cars, facial recognition, projects that work with data to get something done, for those, we have to use programming today because of the nature of the level of project that we're currently at in terms of complexity. We have to use programming. And of course, to expand your resume, you can learn Python to get hired at a higher rate. And Python is free to use. You don't have to pay to use Python. It's open source, which means it is free to use and free to see how it was made, even free to alter it if you want to alter it for your specific use. So those are all some reasons why we see this move from just using Excel for projects to actually now requiring programming in order to build more advanced projects and to keep up with the speed that you're expected to work at these days in terms of the efficiency of your algorithms, the efficiency of how you work with data. It's much faster to work with data when you have a programming language. And you'll see that in the course when we compare doing something in Excel versus doing the same thing, but using Python to manipulate the Excel file. Next up, unless anyone wants to drop a question about what we've talked about so far, then we can move on to our next topic, which is data science in general. So what do we mean when we talk about these higher level projects, data science, machine learning? These projects that you can build with Python. You can use Python to work with Excel files, or you can use Python to work with other types of files as well. It doesn't have to be data stored in Excel. Python, we'll see it will work with Excel data, but also with other types of data too. So data science. Like we mentioned, Python is the most popular language out there for data science. Data science, after that would be R, the R language. So what do we mean when we talk about data science? Maybe some of you have experience as data scientists, or at least working with data in some capacity. Data science refers to working with data, and this comes in multiple steps and multiple different roles that you could have. First, organizing, collecting data. So scraping the web for data, or getting data already collected and cleaning it, making sense of it, interpreting it to see what is the data useful for. For example, maybe you are working at a company for some product, and you get assigned to collect customer feedback about the product. Maybe you go to social media to see what people are saying about your product. Well, how can you collect the data from social media and format it maybe into Excel? So that way you have some data that you can then make some insights from. So that's all part of data science: collecting the data, cleaning it, formatting it, making sense of it, and getting insights of what is it useful for. Because data could tell you customers are liking your product this month, or customers are not liking your product this month. But then beyond that, how can you get even more insights that are not immediately obvious? And how can you use the data for some project, like to target those customers and maybe recommend them a similar product? So anything really working with data in general, we call data science. Data maintenance, so maintaining the data over time. Data processing, almost always the data that you collect or the data that you get assigned as a data scientist, it's going to be messy, it's going to be noisy. So that means that it has some issues that you have to fix. So all of that is also part of data science. Analyzing the data, and this is where we get into programming, like for the collection of the data. If you want to scrape data, which means you automatically collect it by running a bot or running a script, that requires programming. Lots of times you have to do this to collect data. You have to write a script to find the data that you want. Data analysis definitely requires programming. Maybe you've done some data analysis in Excel, run some formulas on your spreadsheets, built some charts to see insights from your data. But to go beyond and do really fast data analysis, we can use Python, and we will see how to do that in our course. Data visualization is also part of this data science field. Taking the data you have and visualizing it into charts, graphs, or taking your analysis results and visualizing those. So that way you can communicate them to an audience that maybe doesn't have any experience with data science or programming. So being able to properly format the data to communicate to your business team or to your audience what the data can be used for. Can it help the company advance in some way? So all of these are different phases or parts to being a data scientist. If you're building your own project and you are managing the whole project, then you will have to do all these steps on your own, or most of them. But if you're working at a company or with a team, then depending on the team, you might just have a very specific role. Like you might just be in charge of collecting data about the company product. And so this could be seeing the engagement with the product. Like if it's an app, collecting engagement data about the app and making sense of it and formatting it and maintaining it and figuring out what other kinds of data can we collect that would be useful. So depending on the project, where you're working, what you're working on, you might be in charge of a small portion of the data science realm, or you might be in charge of the whole thing. If I'm building my own project, I have to collect the data, I have to clean it. I have to analyze it. I have to try to make sense of it. What can I do with this data? That is an introduction to data science in general. And programming really helps us out with data science because you can do all these tasks with scripts. I don't have to manually go to my social media and collect all of the customer reviews by hand. No, I can write a script to do it for me. So instead of having to copy and paste all the user comments about my product and then trying to figure out, okay, do users like it or not? Instead, I can scrape that social media data with Python, and then I can even use Python to tell me the average sentiment, which means the average appeal of the product. Because as we'll talk about with machine learning, you can analyze text without even the human eye. You can use Python to analyze all of your customer reviews and then tell you 60% of your customers are enjoying the product this month. And you don't have to read a single comment because Python can do it all for you with the scripts that you create. So very powerful stuff. Our next topic is machine learning itself. So all of these topics, they work closely together because likely you'll be building a project that uses data, which could be stored in Excel or some similar format. And you're using Python to work on the data. And that's data science. And you might even go beyond that and then use machine learning, which would be a next step. So what is machine learning and how is it related to Excel, Python, and data science? Let's talk about that next, because in our 8 weeks, we will learn how to use Python, how to do data science with Python. And we'll also go beyond that and even get into machine learning. We will build some machine learning projects. So machine learning is actually invented thanks to data. Without data, we could have no machine learning. And that's why all these topics work together. Because of the massive amounts of data that are being generated constantly, we're able to train what are called machine learning models or machine learning agents, however you want to call it. Machine learning is a subset of the artificial intelligence umbrella. So when you build a machine learning model, you can say that you're building artificial intelligence. Now, you're not building a robot that feels emotions, but you are building a form of AI because machine learning is one branch of AI. Technically, machine learning is using computer algorithms, which is code or scripts, like Python scripts, using code to find patterns in data and get some result from those patterns, like a prediction. So what does that mean? Well, let's say you have a bunch of data. Maybe continuing on with our example of the social media data that we've scraped about our product. Sure, I could look through all that data on my own and try to figure out, are customers enjoying the product? I could read the reviews and keep track. Okay, seems like this comment is positive, this comment is negative. Okay, this person seems neutral. My goal being to use my data to make some decision or prediction or insight into the product. Are the customers liking it or not? Doing this manually would take, well, 100 years possibly, depending on how much data you have. If you're a popular product and you have 100 messages a day, it's going to be way too much work for the human eye to read all that data. So that's why we have to use computer algorithms, which just means code. We have to use code to do the work for us. So instead of me reading all of the comments, which I wouldn't want to do anyway, reading comments, but instead of me reading the comments to try to figure out, and tell my team, okay, the product seems to be doing well, but they're having this issue, many customers are seeing this error, or they don't like this feature. Instead of me going through that myself, I can use code to go through the data. This means I can build a machine learning model which will read all the comments for me and then tell me at the end some insights like users are 70% of users are enjoying the product. And that is one example of a machine learning model. How it does this is first it gets trained on data. So you have to train your model to learn whatever task you want it to do. So if I want my model to be able to read my comments, I have to train it to understand comments. So you would train your model for its specific task, and then it would be able to do the task for new comments. And it would be able to analyze the comments and tell you, okay, this comment had positive sentiment, which means that this comment was showing that the user liked the product. This comment has negative sentiment, which means that the comment shows that the customer did not like the product. Now, that's just one example of a machine learning project and a machine learning model. But there's a huge range of different projects that you can build. But the same pattern comes up again and again, where you have data, your model is going to learn or train on the data and give you some insights, like 70% of customers are enjoying the product. And we'll talk about some more examples shortly. That is one common example. But other things like self-driving cars, facial recognition, and many more, which we'll talk about, all of those are also machine learning. So there's a huge range of exciting projects that you can build. In our course, we're going to show you several machine learning projects. We'll create them from scratch together with code. All these projects you can build with code. You need code and you need data, because the only way that you can train these models is by feeding the models data. That's why today, with more and more data generated each day, we're able to build more powerful models every year. You know, we see better and better deepfakes and chatbots and translation bots, speech-to-text bots. We see better and better models every year because more and more data is generated each year by you and me, everyone around the globe. And also because there's more research every year into building models. Okay, we have a comment from Albert. How does it interpret positive versus negative sentiment? Example, please. Okay. So you would feed, one way is you would have a bunch of data to train your model. This could be an Excel file. And in that Excel file, you would have a lot, but it could be like 100 different comments. And this is called your X data, your input data. You would also have a list that says the sentiment of all those comments. And this is to train the model. So you would train it and say that, let's just write a new slide here. If there's a comment that says, I like this, you would say that that is positive. If there's a comment that says, this sucks, that would be negative. If there's a comment that says, this product is okay, well, that could be neutral. So you would have an Excel file or some data file that has a whole bunch of these comments. And this is called the training data. You have to train your models for whatever task you want. This is a specific task where you're going to train the model to recognize patterns in text. So next time the model sees something similar to I like this, like it says, I kind of like this, it's going to look for patterns of where it has seen something similar before. So if it's seen the word like, then it's going to sway positive because it's going to learn on this training data. So if it sees something new, it's going to look through its history and then make a decision based on what it's learned. So that's how the model learns, is on your training data. So I would train my model on an Excel sheet, and the model would be able to learn how to differentiate between comments. These are positive comments, these are negative comments. The model is trained and ready. Then I can send it to the real world. I can get some new comments, maybe some new Facebook comments today, and I can give them to the model. And the model will tell me, based on what it has learned, what it predicts for that comment. And so yes, that's one example. And the model does this really fast. I could have 1 million comments, which I probably wouldn't store in Excel because that's a lot of comments. Again, another limitation. I could have 1 million comments and the model could read through them really fast because it's a computer that can run a script. For me to read the 1 million comments, it would take me, well, can never finish reading them. But for a model, it can read those 1 million and tell you 50% of them were positive because of its training. Albert says this is cool. Yes, I think it's very cool as well. And let's see, we can check the curriculum to see if we have this specifically in our project. Okay, let's see. I'm just going to go to a different page because our site has been lacking on Firefox. But yes, this is actually not that hard to do. It might sound very impressive that the model can, read text and understand it like a human, but it actually all comes down to the code and the math behind the model. But we don't actually do much math at all until you get to extreme advanced machine learning. That's when you would implement more math. But for our purposes, we don't need that much math because the model is not actually reading it like we do. It reads it by vectorizing the text, which means converting it into numbers and then working with the numbers. But that's more into the nitty-gritty of the behind the scenes of the model itself. So don't worry if it sounds too complex for now. Okay, so yes, I'm going to check the curriculum. Week 1, we learn linear regression. Week 2, we learn Python. Week 3, do linear regression again in Python. Week 4, we manipulate Excel files. Same thing, week 5, week 6. Okay, so in week 7, we'll learn how to work with stock data to make stock predictions. And then week 8, we will build more machine learning projects. So in week 8, we can cover this project. It depends on what my students are specifically interested in. But likely around the last week, we would be able to build a project like this. Because to get to this level, we have to first cover the basics of programming and the basics of data science, and then we can get to projects like this. So we would do this around week 8. And this is actually one of the more simpler machine learning projects. Machine learning projects can get very advanced, and we do see this today, but that's typically at large companies with large amounts of funding and research for it. Albert says, can we import positive sentiment words from ChatGPT? Well, it all depends on where you want to get your data from. If you want to get your data from ChatGPT, then yes, you can get your data from there. Whatever data you want to work with, that's under your control. You're the one that can collect the data or generate it. Great questions. Let's talk about some more examples. So this is a very simple example of machine learning because there is a huge range. So far, we've barely even covered what machine learning can do at all. There's so much that it can do. And we see it put to use more and more each day and even in our daily life. So this is a visualization, just a cartoon really, of a machine learning model called linear regression. And this actually borrows from statistics and even just linear algebra. And that's why it's one of the more simpler models. But models get much more complex. There's a range of projects with simpler models versus more complex models. So when we learn, we'll start with the simpler models, but then as you learn, you can build more and more complex projects. But here, this is a type of model used to make typically value predictions, like predicting the price of a stock. For that kind of project, you would get a bunch of stock data, like maybe 5 years of Apple stock. You would train the model to find patterns in that stock data. And then you would use the model, once it's been trained, to predict what will be the price of the stock tomorrow. So that's one example, but the same kind of pattern applies to any kind of data where you predict a value. Like it could be the price of milk at the store. You can take 5 years worth of milk prices as your data and then use a machine learning model to train on that milk data, and then use the model. Once it's trained, it can make predictions. It can tell you what will be the price of milk tomorrow based on the historical data. And it's called linear regression because it uses a linear equation to make its predictions. And this is one of the more simpler equations because behind the scenes, machine learning does use math. The more advanced models, the more advanced the math. But for just starting out or building even projects like this, you don't need much math at all. It's once you get to more advanced models that you need more requirements of learning the math behind the models. But don't be scared away by the math if you're not a fan of math, because for the beginner projects, there's hardly any involved. Another example is object detection or image recognition along similar lines. So this is another subset of machine learning of what it can do under the computer vision subset. Computer vision is all about teaching a computer to see like the human eye. You know, when I look around, I can see my computer, my keyboard, I can see the chat. But how do we train a computer to do the same thing? Specifically, a computer means code, or a machine learning model, to be even more specific. How can we train a machine learning model to understand visual data? Because so far we've seen that machine learning can work on text, like comments. We've seen that it can work on values, because it's one of the more simpler types, because it's trained for numbers primarily. But also, machine learning can work with other types of data, like PNG files, JPEGs, video files, video frames from the video files. So machine learning has huge applications for many different types of files, not just numbers, like you probably work with numbers in Excel, not just text in comments, but even beyond that, like images, sound waves, sound files, audio files, video files. So there's a lot of power in the projects you can create. So this one is an example of computer vision because the model learns to recognize objects in images. Along similar lines would be projects like motion detection, where a model is trained to recognize when something comes into frame of a camera. And so that's how it can detect motion. Along similar lines is facial recognition as well. You know, if you have an image of a person, or maybe someone's doing the facial recognition to unlock their phone, how does the computer or the phone, how does it recognize who you are? Well, likely today it's using machine learning to do so. And it all is using the same kind of idea, machine learning. It's using data to get a result, or get some insight, or get some prediction. The data in this case is just image data. So instead of numbers or text, machine learning can work on other data like images. And so if I wanted to train a model to recognize cats, what I would do is I would feed it, or train it rather, I would train it on images of cats versus images of other stuff. And it would learn the patterns in the images that lead to cats. versus patterns in other images that lead to trees or dogs. And there's many different techniques for this, but one way is it can recognize the edges that are created by the cat shape. Because if you outline a cat, it has a different outline compared to a tree. That's just one way of doing object detection. Because an image is just a bunch of data at the end of the day. An image is a bunch of pixels. Like if you have a 50 by 50 pixel image, means you have 50 times 50 pixels. So you have 2,500 pixels. Each of those pixels, if it's black and white, it's going to be either 0 or 1. 0 for black, 1 for white. If you have an image with color, then you're going to have 3 values per pixel. You're going to have the red, the green, and the blue, which mix together to create every color. So that's how models can work with images, because any type of data, it's always going to convert it to numbers. An image, that's how it converts it to numbers, because pixels have a color value. Every single pixel in this image has a value of 0 or 1. And because it's an image with color, it actually is three-dimensional. It has, per pixel, it has 3 values of 0 or 1. Same thing with text. The models convert text to numbers. And that might sound weird. It's called vectorization, text vectorization. But it's because models cannot read text. We're not training a human. We're not teaching a child how to read. We're not teaching a model to look with some robotic eye connected to a brain. No, we're actually just training code, which uses math to find patterns. So that's why all the data it works with, even if it's a sound file, all of that actually gets converted to numbers. And that's how the models can do it. So it's not no magic, it's just converting the data into numerical format. Don't worry if it sounds complex now. I know I'm throwing a lot at you, but there's a lot of projects you can build, and we'll start from the ground up. So we'll start slowly with some projects that you can understand with ease, and then we'll increase each week the complexity. I'm not going to have you building a self-driving car on week 1. It's going to take some time. So this is another example, object detection. You might be thinking, what are these 0.98s? That's referring to the confidence score. So the model can give you a confidence score. So the model might be able to recognize 10 different objects: dog, person, cat, tree, desk, computer, laptop, keyboard. And for each object in the image that the model detects, it's going to give a confidence score for all of the labels that are possible. So it will say 98% dog, and then 0.01% cat, 0.005% tree. So it gives a confidence score, which means it's 98% confident that it's a dog compared to all the other objects that it's been trained to learn. So you train your model on your specific use case. This is just one example of how it can detect cats. It was just through edge detection or the contouring, finding what general shape will typically cats create in the images. Another example of machine learning is here with grouping or classifying data into different groups. For example, maybe you have a bunch of biology data about samples, and you need to somehow differentiate the samples. Well, in some projects, maybe you already know the samples that you're looking for. But in other projects, you might not even know what data you have and how it can be separated into different species. The model, machine learning models, can actually either work with data that you already know what you're looking for, or it can give you insights into possible differentiations between the samples. And this is quite powerful because it means you don't have to assign labels to your data. The model can find differences on its own. For example, if I'm training my model to recognize dogs, persons, or cats, One option is to actually train it. Okay, these are dogs, these are people, these are cats. Or you could just give it a bunch of images and tell it to find the differences on its own. And then the model will learn on its own that there are 3 different types of images or objects that can be found. And how it does this is through patterns. The dogs in the images will always have a similar pattern. The people will always have their own pattern. The cats will always have their own pattern. And so the model can tell you, okay, there are 3 distinct patterns that I'm seeing. And you don't even have to tell it that there are 3 patterns or which patterns they are. It can find the patterns on its own. So that's called unsupervised learning. So that one is quite powerful because you don't have to do the work of labeling all your data. Another example here is logistic regression. This is where, again, you're classifying some samples, but you're only classifying them into 2 possible binary categories. For example, let's say you're working at a bank and you want to build a machine learning model to help you determine or make a prediction on if a profile would get loan approval. You can use different features about people's profiles and make a prediction. Based on their profile, would they get approved for a loan? And this way you can quickly assess your profiles, at least at the preliminary stage. So you could use logistic regression for this. One feature about a profile could be the profile's income. So based on the income, would they get approved for the loan or not? So if the incomes fall in the lower half, we'll sort them into no, whereas if the incomes fall in the upper half, we'll sort them into yes. And this is just one feature of the profile, but typically you would combine multiple features and then make your prediction based on multiple features, not just one. So that's another example of machine learning where you have data about profiles and you're making a prediction on will the profile get approved for a loan. So hopefully you're seeing the patterns come up again and again where machine learning is all about taking data and making some prediction from the data. There's a huge range of data that you can work with, which is what creates the huge range of projects that you can build. I also have an example in code to show you to get your feet wet with some of this code. So I will drop a link in the chat where you can follow along. Okay, I'm going to reconnect to my runtime and show you this example. So this is an example of how you can build a machine learning model. So it's all done with code. And this is an example of linear regression, which is the most simple of the model types that you can create. But there are many different types of models that you can create depending on the project that you want to build. So don't worry if you don't understand this code. I don't expect you to understand any of it because I expect most of you don't have coding experience. But don't worry, in our 8 weeks, we will train you on how to understand and even write this code yourself. So by the end of the 8 weeks, you'll be able to build projects like this on your own. But just in general, first you would import some helper libraries that you would use, which is helper code that will help you to build your project faster. Then you would either collect your data or generate it. So this one is just generating some random data just for quick testing. Then you can visualize it to get some insights into what is the trend in the data and get some ideas of what could I do with this data. So this data is very simple. It's just 6 data points. And not very realistic, but I just wanted to show you a very simple example. And this is the data science phase. All of these phases are related. You know, your data might come from an Excel file. And now we're using Python to do some data analysis, some data science on it. and prepare it. Then we can give it to our machine learning model. So all of these topics, they all work together. So then you train your model on the data, and you can evaluate the model, and then you can test the model and use it to give you some prediction. That is the life cycle of a machine learning project. And don't worry if you don't understand the code, because that will be the job of the 8 weeks. And this example here is Python code. This is what Python looks like. So in this course in the spring, you will learn how to write Python from scratch and how to use it to do data science and machine learning. Very exciting field with tons of opportunities for work and just building projects in general, building your own side projects as well, like many popular apps. They use machine learning. So it's quite an exciting space. So for the course itself, I'll drop a link in the chat where you can read more about the course. You can see the curriculum and you can enroll. Our last class sold out, so don't wait until the last minute. If you add 2 courses to your cart, you will automatically get 10% off. So here's the course page. I recommend using something like Chrome because we're having some issues on Firefox today, or at least I am on my computer. So this is the course page. You can read more about the course, and you can also enroll now. So let's just go down here to the different plans. We have 3 different plans that you can choose. The first one is the self-directed plan where you learn on your own. The second one is the live classes plan where we meet every week and we talk live and we build projects together live. And the third one is the tutoring where you have everything from the previous classes, but also extra tutoring time on top of all that. Yes, Albert, please ask away. You can always ask questions. Feel free to ask questions anytime. The live classes are starting very soon, so you can select options. The course begins on the last day of February, and the course length is 8 weeks. We will have 1 holiday break at the end of March, so we'll have some time where you can take a break. Oh, let's see, Albert, I don't actually hear you. I'm not sure how that works, but you can type in the chat. I'm not sure how to get audio working. But feel free to type out into the chat. And we can work on audio comments for next time. So yes, feel free to type away into the chat. Sorry, I can't hear you live. So we meet every Tuesday at 8 p.m. Eastern, which is 5 p.m. Pacific time. If you have more questions, you can also email us or send us a message on Circle. If your question is very long, then you can feel free to take time to type it out and get back to us on email. So let me just drop a link to our team email, alicia@lumiwealth.com. You can also book a call with us to talk extensively at a later time. Right here, book a call. I'll drop a link to that into the chat right here. That way you can talk for a more extensive period of time than today. So if you'd like, you can pick a date here on our calendar at that link for booking a call, and we'd be happy to answer any questions then as well. Always happy to chat. You can also message us on Circle, send us a direct message, or just make a post, and we will get back to you on Circle too. So we're always happy to chat, even if we can't hear you today. So yes, we also have payment plans available. So you don't have to pay all at once. You can pay over 3 months or 5 months. You can select one of the options and then go to the cart. And just like that, you can enroll. Whenever you enroll in a course, you immediately get all of the course library that's already present. Now this course is brand new, so we actually don't have any course library just yet. But for other courses, as soon as you enroll, you can already see all the previous semesters. Because at Lumiwealth, you're a student for life, so you can watch back courses from all semesters, and you can watch forward in the future. When we run this course again and again, you can watch it again and again. So this is quite unique because at universities, they force you to pay again for the next semester. But not at Lumiwealth, you get all the semesters for life. So you can place your order just like that with the checkout. If you want, you can click to pay with a payment plan if you don't want to pay all at once. And we also have invoices for employer reimbursement if you need help with that. So that is how you can enroll. You place your order and then immediately you have access to the course library if it is an already existing course. And if you add another course to your cart, then you automatically get 10% off the cart. So right here, you now have a 10% discount. So I'm excited to bring this course to you in the spring. It's going to be a great semester, brand new, fresh course, fresh content, never done it before. So I'm very excited to bring you some of my favorite data science and machine learning projects for beginners. So don't be intimidated. It's not too hard. Anyone can do it. So I'm excited to bring it for you in the spring. If anyone has further questions, feel free to ask now, or again, message us anytime and we'd be happy to chat. Thank you so much for joining me, everyone, tonight. And remember, we will be recording this, so you can watch back on YouTube or Circle at lumiwealth.circle.so, where we have our online community, where you can post questions and you can watch back these recordings and message instructors. It seems like no one has any further questions, so we can wrap it up here. Thanks so much for joining me all. And we'll have more free webinars next week on other topics, so please come back for more free webinars. And I will see you in the spring for this amazing course. Bye, everyone.